Okay, so today we're going to continue with our design of an array-based list to see how these kind of data structures work. And we're going to continue our design by following this, this basic outline, right? We're going to design the interface first before we even get started on an actual implementation. This is akin to what you've been doing with your ER diagrams and your UML diagrams where you whiteboard it first, right? How do I want to be able to interact with this list? And then we're going to design tests because we don't want to start immediately implementing our list because we want to know whether or not it works. So I'm going to write some ad hoc tests. Now, normally if this were a real project, if this was real life, then I would be writing formal JUnit tests that are repeatable. And as we'll see here in a second, when I do ad hoc testing, it's not repeatable because I'm just testing as I go along. Then we're going to actually implement the interface, and this is a feedback process. We're not going to get the design 100% correct on the first try. We're not going to get the tests 100% on the first try, and we're not going to get the implementation 100% on the first try. So we're going to have to go through that process over and over and over again until we get everything right. We realized from our implementation, oh, well, you know what, it'd be easier if the interface looked like this instead. The tests actually didn't pick up on this, and so I need to add some more tests. It's a never-ending process of reiteration and refinement and drafting, right? That goes all the way back to the discussion on technical writing and how the drafting process is similar to the coding process. So let's just remind ourselves of where we were last time. This is my integer array list. And we have this default starting capacity of 10. We implement it using an array. So initially, we can't get away from that. We have to store data somewhere. And since it's an array-based list, we're going to be storing it in a list. But we need to keep track of the size, because when I create an array of size 10, that's its capacity. I haven't put anything in there yet, right? It looks more like the following, right? Let's go ahead and like this. But the capacity is 10. Oops, 10, there we go. But the size is going to be 0 because there's nothing in it yet. Nothing's there, all right? As we put stuff into it, then the size is going to grow, right? It's going to, if we put 10 in there, now the size is 1. If we put 20 in there, now the size is 2, ... Eventually, if we fill this up, so it's 10, 20, 30, ... 100, and we've now reached the capacity, we need to take care of that situation. We need to create a larger capacity here in order to insert 110, say. Right? So that's where we're going to pick it up. Right? That's what we did here, in fact. That's what we did last time. If the capacity is already filled, in other words, this size is equal to the arrays list, and this is our version, right? Yep, this is our version. Then what we needed to do is we needed to create a larger array, copy everything over, and then make this list's array point to the new array. But guess what? We could do that all in one line of code by simply just reusing what was given to us as part of the arrays library. Right? So I'm going to go ahead and get rid of all that. There. And now what we do is we add x, knowing that we have that capacity, and then we increase the size here. Okay? Remember that the behavior here is that it adds it to the end of the list. Okay? Now we need to add, we need to do this method, right? It's going to add an element to the given list at the given index. Before we do that, did we test it though? Let me see. Actually, we did test it, right? In fact, we tested it really large numbers here. I'm going to go ahead and bump this down to 100, right? And then we're going to print these out. Let's make sure that we didn't break anything there. Right there. 10, 20, 30, 40, 50, 100. Before I continue though, let's make our lives a little bit easier. Right? What is this piece of code doing here? It's printing out the contents of the array, of the list, right? That sounds like an X thing. It belongs in the X class. Fill in that X for me. Formatting the list as a string is a blank thing. What is that blank? A list thing. Where does it belong? In the list class. Does it belong here in the demo class? Nope. So let's come over here and add some functionality. Right? So I want to be able to convert this list into a string so you can print it, right? Right. Convert, in other words, format this list into a string so that you can print it. What kind of a function does that sound to you? It's certainly going to be a public function because I want somebody to use it, right? And it's going to return a string, right? So should I call this function awesome function to convert to string? Right, there we go. I'm not even going to format it correctly because is that a good name? Right. Don't we already have a name for this? ToString, exactly. Everything has a ToString method, right? Let's go, in fact, let's go ahead and get rid of this for a second, and let's come back over here and just simply print out the numbers list here, right? Don't get the ith element, just print out the entire numbers. Everything already has this ToString method. Remember that there's 10, 20, 30, all the way to 100 there? Right? There. That's the default behavior, remember? A fully qualified path along with the Java virtual machine memory address at which you can find it, right? So we need to override this method, right? So again, remember with your project, formatting an item, that sounds like an item thing. It belongs in the item class. Formatting a product sounds like a product thing. It belongs in the product class. Formatting a detailed sale sounds like a sale thing. It belongs in the sale class. You just need to follow that pattern everywhere, right? And that should, when you write a piece of code, ask yourself, where does this belong? Well, the first question, the answer is, what does it do, right? It does an X thing. Where does it belong then? It belongs in the X class, right? So ToString, again, I have this arrays.ToString, this.array. Unfortunately, that's not going to be great, because if I bump this down to 50, we're going to get something that looks like the, oops, I need to return it. Return. Right. Return. Remember, the first question you ask yourself as an engineer is, has somebody already solved this problem? And somebody has already solved this problem, but they haven't solved it in the way that we want. We have 10 through 50 here, but it ends up printing out all those extra zeros. Remember, that's our capacity. We have a capacity for 10. We've only put 5 elements in there. We do not want to print out those trailing zeros there. So let's come over here, and unfortunately we're not going to be able to use that. Instead, let's go ahead and use our old friend, the string builder. SB is equal to new string builder. SB.append a beginning square bracket, no space. Right? SB, and then for int I equals 0, I is less than this dot size, I plus plus. SB.append, what is it going to be? This dot array sub I, and then we can also append a comma space, and then at the end we can go ahead and append unclosing square bracket, and then return SB.ToString. It's not going to be perfect, because we're going to get that trailing Oxford comma there, coding Oxford comma. If you really care about that, then you can go ahead and stop short, right, by 1, and then just append the last one, this dot size minus 1. So again, when you're writing a basic loop in any language, you might have to handle the first iteration or the last iteration or some combination thereof outside of the loop, right? And in this case, we've got that. Now I don't have to worry about the details of printing it out anymore over here. They are encapsulated inside the class and abstracted away so that I don't have to worry about it. All right, wonderful. Now let's worry about adding to an arbitrary index. Let's think about this on a piece of paper first. Suppose that I have 10, 20, 30, and 40 already in my list, okay? And I want to insert 42, right? At index, say 0. What does that mean? If I insert it at index 0, remember that we have indices here 0, 1, 2, 3. So does that mean that I'm going to replace that and then put 42 there? No, it means I'm going to add it, right? All right, so undo, 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 go back. What's it going to look like? when I add it to 0, I am going to need to shift everything over in order to make room for it so that I can insert this new element here, 42. Okay? All right. That's what it would look like for 0. What would it look like for 1? That means that I need to insert, 0 means that I'm inserting right here. 1 means that I'm inserting right here. And that means that I'm going to have to shift all of this stuff down by 1, accommodating 42 right here. Okay? Let's undo that. And let's think logically about how the end, how it might look at the end here. 0, 1, 2, 3, 4. Well, if I insert it at 3, what does that mean? That I'm going to shift 40 down. Okay? But what does it mean that I'm inserting it at 4? Does that, I'm just adding it to the end. Hey, wait a second. Do I have a function that does that for me already? Yeah. I wonder if these two functions could be consolidated somehow. We'll worry about that here in a second. But otherwise, there. Now, what else could happen here? Does it make sense that you'd be able to add it to index -1? What does that mean? I'm going to insert it right here. Inserting at the front, I've already got that, right? That means 0. I'm going to insert it at the front and shift everything down. Right? So what does it mean that you're going to insert it at -1? That means that you're going to put it over here at 42, and then there's a gap here. That doesn't make any sense. Right? So should we allow that? Probably not. Right? There are some programming languages that work like that. Python, for example. If you have 5 elements here and you have a negative index, what happens in Python is that it wraps around to the end. Right? Likewise, if you go beyond it, I think, don't quote me on it, but I think that it goes back around to the beginning or something. Right? This ain't Python. Right? We have an expression, when in Rome, do as the Romans do. When you're in Python, do as Pythoners do. They call it the Pythonic way. Right? Whenever you're doing something in Python, you need to conform to how they do things. We're not in Python. We need to conform to how Java does things. So what does it mean to say -1? What does it mean to say 5? Right? These two things to me mean error. And how do we do error handling in Java? We throw an exception. Okay? So my first thing that I'm going to do is I'm going to check those indices. Step 1, error check. If bad indices, throw an exception. 2, right? Just like up here, you're about to add an element. If you're about to add an element, you need to check the capacity. Check the capacity. If not enough, increase the size. 3, shift stuff down. Right? To make room for X, right? And then 5 or 4 here, insert X at index at the index, the given index. Okay, there's my outline. Okay. Now, what's an invalid index? Well, certainly if it's negative, right? If index is less than 0, then I will throw a new, I don't know, illegal argument exception. Negative indices are not allowed. Right, there we go. Else if index is greater than or equal to or something like that, right? Then I'll throw in another illegal argument exception here that says index cannot exceed something, ... You tell me. All right. So let's come back over here to our whiteboarding example, and let's determine what would be a bad index at this level. What is the size of this list right here? 4. Was the index 4 okay? Yeah. That means that you're just inserting it at the end right there. Was an index of 5 okay? No. So the relationship here is if it is strictly greater than this dot size, right, then the index cannot exceed this list's size. There we go. Wonderful. All right. Now let's check the capacity. If it's not enough, increase the size. Hey, I know how to do that. We already wrote code to do that. Copy, paste. Is copy paste a good idea? Is that a good pattern to follow? That should be a huge red flag. That's what we call a code smell, right? It doesn't necessarily mean, I mean, there are bad foods, there are foods, excellent foods that smell terrible. Doritos, right? As long as you're eating Doritos, at least for me, as long as you're eating Doritos, they're fine. But if somebody else is eating Doritos and you're not, they stink, right? Is anybody else like that? No? Okay. Anyway, there's plenty of foods like that, right? They just, it stinks, right? So, but it doesn't mean that it's necessarily bad, because Doritos are still good, right? Cool Ranch is better. Or actually, no, what are the Blazins? Blazins are, what are the really hot ones? What are they got? What? Nacho cheese? No. No, that's not the hot one, man. They're flaming hot, yeah, there we go.
Yeah, and there's also a sweet and spicy.
I don't want sweet and spicy, I want hot, man. Anyway, it doesn't mean that it's bad, right? But it means that there's probably something up that you should check out, right? For example, I have repeated code here and here. What's a better idea? Put it into a function. Here's my first version of it. Public void increase capacity. Capacity, there we go, right? I'm gonna put that code down here so that I don't have to repeat it. Right? Instead, up here where I increase the capacity, I'm going to call that method, this dot increase capacity. So I don't have to repeat that code. And up here, so I don't have to repeat that code. Nice. Right? That was my first version of it. Except that now let's take a look at from outside over here. Numbers dot increase capacity. Is that something I should be allowed to do over here in the demo class? No, that's a leaky abstraction. In fact, what if I required you to do that? Right? Oh, before you add another element, check to see if the capacity is not satisfied, or it's full, and if it's full, then go ahead and call this function over here. The whole point of writing these things is so that you encapsulate all those details inside the class. That increasing the capacity, that's a list thing. Where does it belong? In the list class. That's not my responsibility. I'm the demo class. Right? That's the list's responsibility. So consequently, I am going to take this away from the interface. I'm going to make it private. Right? I'm still going to document it to do write documentation. Right? We could do that really quick, actually. Increases the capacity of this list by default capacity. Default capacity if it's full. If it is full, right? Again, if it's full, there's the condition there, right? There, that's good documentation, right? But now that it's private, I am not allowed to call that. In fact, I never even see it. I don't want to have to see it. Do you want to have to know how the square root function works in order to use it? No. Do you want to know how the list works in order to use it? No. We keep stuff in that class. Again, object-oriented programming. Right? All right, now let's go back to our outline here. Another good reason that you write an outline is because when you think, oh, okay, this needs to be done, so I need to go and do that, then you can come back and where was I? Oh yeah, right here. Right? Shift stuff down to make room for X. Right? Let's look at an example. In fact, let's look at that same example for a particular value, 10, 20, 30, and 40. I want to insert 42 right here, right? At index equals 1, okay? That means that I need to shift stuff down. Should I just immediately go ahead and shift 20 over here? What do I end up with? What happened to 30? That's gone, right? Okay, I don't want that to happen, so maybe I should shift 30 first. And now 40 is gone, right? So let's back all the way up, right? What should I do first? Remember, I've already increased my capacity, so we're good on that front. But shift 40. Right? Well, what was over here before? Who cares, right? 40. That frees this up so that you can put 30 over here, right? That frees this up so that you can put 20 over here. that frees 20 up so that finally you can put in 42. In other words, we're going to start at the end, and then we're going to work our way down the list. Instead of the traditional for loop that goes I++, we're going to go down. We're going to copy the ith element over to the I plus 1th index. All right? Okay, let's write our code to do that. For int I equals, where are we going to start again? At the very end. Where was the very end here? Remember, before this, the size was 4. So I started at index 0, 1, 2, 3. So where do I start? Size -1. Right. I is something something. I minus minus. Remember, we're working our way down. Okay. And I'm going to copy the ith element to the I plus 1th index. Right. So this dot array of I plus 1 is equal to this dot array of I. All right. Now when do I stop? Let's come back over here to our example. I need to make sure that I'm copying the indexed value over. So I need to make sure that I am copying that. And I go up down to while I is greater than or equal to index. Remember, the index was given as part of the input. Right? So I'm going to start at the end. I'm going to be copying things over and over and over until I get to the last one, the one at index. And then once I've copied that over, now that frees this spot up here to insert x at the given index. This dot array of index is equal to x. Careful. What else do we need to do? We need to increase the size. Right? Remember, we've already increased the capacity if we needed to. Right? And by simply having a function here that tells me that's labeled increase capacity, I know that it's been increased. Right? All right. Let's see if that works. So let's print it out. 10, 20, 30, 40, 50. Good. Now let's go ahead and insert something at an arbitrary index. Numbers dot add x. Let's go 0. Let's go -1. 42. What are you going to expect out of that? I expect a exception. Index cannot exceed this list size. Oh, sorry. Is that backwards? Oh, it's x and then index. So let's go ahead and move these around here. -1. Right. There. Index cannot be negative. Right? That's what I'm expecting. What if I didn't have that, by the way? What if I didn't have this basic error checking? How would it behave then? Let's try it out. Oh, I still get an error, right? But array index out of bounds? Wait a second. Do you see an array here at all? I don't. I see something called array list, but I don't know what that is. Right? I just know what an array is. But do you see an array here? I see one right here, but that's not relevant. That's the arguments. Right? In other words, letting the default error handling take over will start to leak the abstraction out. This is telling me, this is giving me information that inside the class, you're using an array. Oh, okay, wow. Maybe that's information that I could exploit. It's certainly not information that I need to worry about, or that I want to know, or that I want to worry about. So by checking and throwing my own exceptions over here, I've taken that burden away, that leaky abstraction away. Right? Illegal argument exception. Oh, okay, I know about arguments because I gave you the arguments right here, these two. The negative indices are not allowed. Okay, now I understand that. All right, let's go ahead and insert it at 0. I would expect it to be 42, 10, 20, 30, 40, 50. And it is. Right? All right, I don't know why it's so slow today. No, OBS is doing fine. Anyway, if I inserted at 1, then I would expect 10, 42, ... If I inserted at 2, then I would expect 10, 20, 42, ... Right? Let's go ahead and test the other extremal element here, 5. That's going to be inserting it at the end. and that works as well. If I go beyond that though, 6, then it cannot exceed the size. There, index cannot exceed the list size. Okay? Let's kick that back down to 3. Okay? Now, again, I want to highlight that we are doing some tests, but these are ad hoc tests, right? These are not formal tests. These are not repeatable. If I go and change something, refactor something, right? I would have to go through that entire process again to make sure I didn't break anything. And only if I've got it in a unit test, like a JUnit test, like you have in all of your the labs and in the first homework, or in the first assignment, is it repeatable, right? The tests may be wrong, they may be right, we don't know, but